Okay, so this will be serve as the first prep video for Math 270, which is applied calculus here at John Tyler. Before I get started, I want to make sure that you kind of understand how to use these videos. I encourage you to go ahead and take notes, just like you would in class. If you find that I do go a little bit faster in the videos than I do in class because I don't have time, there's no one to ask questions of, there's no one in my audience right now. So I encourage you to take notes, but one option that you might consider is to either pause the video periodically to jot down some things and then start it again, or zoom a little bit into it, find a spot where it looks like everything's written on the board, go ahead and write it all out, and then come back and listen to the explanation. So those are a couple of other options if you feel like you need to go a little bit more slowly. So this is actually not a calculus concept. This you may have already seen in pre-calculus. This is sign charts. And so what is a sign chart? Well, we know how to graph things, right? We graph on an XY axis. A sign chart is really just a compression of the y-axis so that we're really looking along the x-axis but knowing what y is doing in a very compressed fashion. So it helps us get to answers very quickly. So let's think about how that works. So if I were to take let's just take a function like this. And let's say it goes through -2 and 2. Okay, so I could take all of these values up here, and I see that they're all positive. So I could come over here, here's -2, and I could say, well, I've got a +1 here, and then a +4, and then a +6. And so really, I'm not drawing up the y-axis. I'm just kind of logging what those values are. And then down here, -1, -0.5, -0.5, -1, that kind of thing. Of course, that seems really messy. So another thing that we could do instead, and actually I'm not even going to put x = 0 on, I'm just going to put these points where things change. And so I could have pluses up here, and minuses here, and pluses up here. And then finally, kind of our final form that we end up using the most is where we just put all the signs on the one side. So we're going to take this graph, I'm going to line it up underneath here. So here's our 2, and here's the -2. And we have plus here, minus here, and plus here. If you prefer to put more pluses and more minuses, that's totally fine. But the idea is now I know a lot about this graph without actually graphing it, which is kind of cool. So I can answer a lot of interesting questions this way. So let's back up just a little bit and look. Where is the dividing line between plus and minus? It's this point here. What do we call the value on the x-axis? That's the 0 or the x-intercept. So one of the things we need to remember is that x-intercepts are dividing points between plus and minus. And so this example is actually f of x equals x squared minus 4, which we know factors x minus 2, x plus 2. So that's where those zeros, roots, x-intercepts, all the same thing, that's where that comes from. Okay, so let's look at another example. Let's look at y equals 1 over x minus 2. Okay, that, if you may remember, that's a rational function. 1 over x looks like this. That's one you just need to kind of know in your head. This is a translation. Because it pertains to the x, it's a right-left translation, which means it goes in the opposite direction of the sign. So we know that this graph has an asymptote here at 2, and it's going to look like this and like that. And it still has the horizontal asymptote, because as x gets really huge, 1 over really huge is really small. So that's going to tail off. Okay, so again, the whole point of looking at this example is to see how does this compare to a sign chart. And so let's just draw it right underneath. Here's this point of interest at 2. What happens on this side of 2? All the y values are positive. And what happens on this side of 2? All the y values are negative. So what does that tell us? That tells us that in addition to zeros being a point of division between plus and minus, so are vertical asymptotes. So basically what we've said then is anywhere the numerator is 0, or anywhere the denominator is 0, we can put as a point on our number line, and we know that the sign will change potentially between those. Okay, so let's get some vocabulary going. I'm going to write some things over here. I tend to write kind of over on this side in the corner any steps that we're going to do, any process, any information, and I'll just leave that up there so that we can refer to it. So, some vocabulary. a partition point is basically anywhere the numerator or the denominator of your function is equal to 0. And those are the numbers that we're going to put on the number line. So let's write that out. So any zeros or vertical asymptotes, and these points go on the number line. I guess I'll write it out. There is another term we use which is called critical point or critical value, and those are a little bit different. Critical points are all your partition points that are in the domain. So all your zeros would be critical points, but your vertical asymptote values would not be because they're not in the domain. So these are all the partition points in the domain. Okay, so now let's think about, we'll determine a process, but what are some of the questions, why would we do this, right? What is the point of this? One question might be, what if I had this question, solve y equals x squared, solve this. I just want to know where it's greater than or equal to 0. I could graph it and then look, right? Here's the graph that corresponds. I could look and see. Or I could just simply do a sign chart, and I don't even have to graph it. And the sign chart, so the sign chart becomes a very compact, very quick way of answering a question like that. Or answering a question like that. These are really the same thing, right? I can't solve it this way. Remember, for quadratic and any polynomial equations, we need to have 0 on one side, because I know what happens compared to 0. I know where this is equal to 0, above 0, below 0. It's a little bit harder to, I mean, there are a lot of different things that could make something equal to 4, and so that doesn't help me as much. And so what's another question we could answer? We could also answer, we have some calculus ones we can answer. Oh, domain is another one. Find the domain for the square root of x squared minus 4. Well, what do I know about square roots? I can't take the square root of a negative number. That means everything inside, that whole expression must be greater than or equal to 0. So really, several questions that become the same thing. And then we'll use this for some calculus concepts as well coming up. So let's go through the process. Let me write out the process. I'm going to leave these up here. And so here's our process for doing a sign chart. First step is to find everywhere that the numerator and the denominator are equal to 0. So find zeros and vertical asymptotes. Okay, the second thing is put those values on the number line. So put all your partition points on the number line. I recommend using solid circles for your zeros because that's where it's equal to 0, but using dotted lines for your vertical asymptote just to remind yourself which one is which, because that will come into play sometimes depending on the question you're answering. So a circle for a 0 and a dotted line for a vertical asymptote, just like we would draw on a real graph. Okay, now we're going to test some points. We didn't really talk about that, but come back over here. Does it matter which point in here I pick? I can pick any x value. If I find the y value, all the y values will be negative. So I can pick anything in here, anything between the zeros. So usually we try and pick the easiest number, so in this case I would pick 0. So the point is that once you look at the graph, all you need to do is pick one point between partition points. So this third step will be test points. And then in the end, you're going to have something that looks like this, a sign chart with dots or vertical asymptotes and pluses and minuses. But that's not the answer. Now you need to actually answer the question. So that's always the last thing. Answer the question you were asked. Okay, so let's do a couple of examples. And as always through these, once you see me do an example and you say, oh yeah, I got that, that's fine. You don't have to watch the rest of the video if you don't want to. And in fact, you don't have to watch these at all. You could read the book instead. If you have a favorite, Google site that you like, if you really like Khan Academy and you want to look there, that's fine. It doesn't matter to me. Okay, so let's look at solving this. X squared minus 5x plus 6 greater than or equal to 0. In fact, just to remind ourselves, let's change this. So remember, I don't really know, there are a lot of different things that are greater than or equal to negative 6. The numbers are infinite. If I've got a 0 on one side, that really pins things down. So let's always do that first. So x squared minus 5x plus 6. I've just added 6 to both sides. Now I'm going to pull this out. I'm interested to know where this is equal to 0, because that's what I put in my number line. So I'm going to bring this down to this equation. You do not have to write this step if you understand that's what you're doing. How do I always solve a quadratic or polynomial equation? I factor. So x minus 2, x minus 3. You want to be sure that you are able to factor pretty quickly. You don't want to spend your brain power on that in this class. That should be kind of old hat. Okay, so what do we know? We know our zeros are, this one gives us x equals 2, and this one, x equals 3. Okay, so we want to put those on a number line. 2 and 3. Solid circle. Nothing else goes on the number line. Don't put 0 for the origin. Don't put anything else on. Okay, so now what we need to do, and you can include as much of this as you like. I myself have gotten to the point where I can do these really fast, which you might expect, and so I will write a lot less of this myself. But one thing you can do is write your factors here. Right? These are the two factors that gave you those zeros. Now we're just going to plug in some numbers. You can, if you want to, plug in here and get the actual y value. It just takes a lot longer, and so it is in your best interest to get to the point where you can make this a sign chart. So we're going to do signs. So let's pick 1. That seems easy. We're stuck with 2.5, I think, and 4. Okay. I tend to do arrows. There are lots of different ways people do. There are all sorts of different setups for this. This is just my way, and whatever way works for you is great. Okay, so I plug in 1. 1 minus 3 is negative. 1 minus 2 is negative. Altogether, that's positive. Negative times negative, positive. If I put in 2.5, 2.5 minus 3, negative. 2.5 minus 2, positive. 4. 4 minus 3 is positive. 4 minus 2 is negative. Positive times positive, positive. So again, I've gotten to the point where I don't need to do these two lines, but if you do, please do. Okay, so now we've tested our points. Now we need to answer the question. What was the question? Solve this. Where is it greater than or equal to negative 6, which is this problem, where is it greater than or equal to 0? So greater than or equal to 0 is here and here. We always use interval notation. So we start at negative infinity, go all the way up to 2. Because we're asking for greater than or equal to 2, we use square bracket together with, that means there's another piece, from 3 out to infinity. Okay? And all along in class, I would naturally be asking, any questions? Does this make sense? I'm looking around. Here I don't have that, so we'll just move on to the next problem. Okay, so here's one. Solve this one. X squared minus x over x plus 2 greater than or equal to 0. Again, it's very important that you have a 0 on one side and only one rational expression, one fraction on this side. So now the first step is to find all the zeros where the numerator is equal to 0 and all the vertical asymptotes where the denominator is equal to 0. So let's go ahead and factor that. So we've got x times x minus 1 over x plus 2. That's our factored form. So we know that we have zeros at x equals 0. That gives us 1. This one would give us x equals 1. And we know we have vertical asymptotes at negative 2. So for those of you who are a little rusty, what I'm doing is I'm saying x plus 2 equals 0, subtract 2 from both sides. again, that's something you should be able to go from here to here pretty quickly in this class. Okay, so let's get everything on the sign chart. So we have zeros here and here, and a vertical asymptote there. Okay, I typically, when I'm keeping track of pluses and minuses, I kind of keep these in the same order. So I'm going to kind of think of this as this. Just because then if you don't write these lines, you can say plus, plus with a minus underneath, and you know which terms go to which. All right, so let's pick some points. -3, -1, 1/2, 2. So again, we're just picking any point, whatever you, if you wanted to pick -1/10, go for it. You know, any point you want that's in between the partition points. So if I put in -3, I get a negative, and another negative. So altogether, 3 negatives, negative. If I put in -1, I get negative, negative, positive. Even number of negative signs is positive. Put in a half, positive, negative, positive. And then lastly, 2 is positive, positive, positive. And again, I don't usually have this line, so if I were writing this out for myself, I would have this. And I would put in the points I'm testing. I always write those out. And I write them with arrows to make sure that I don't confuse them with the points, the partition points themselves. So I would have minus, plus, minus, plus. That's how mine would look. And it's a little nicer to have not all of this information. So if you can get to that point, that's good. Okay, answer the question. Where is this true? I want it to be greater than or equal to 0. So here and here. So this one, -2 up to 0. I include the 0 because that's a point. This is a vertical asymptote. There is no point there. It's not in the domain. It is not a critical point, so I cannot include it. So open regular parentheses. So this section together with this one. So that would be our answer. Okay, last one. So again, if you need to pause and write some stuff, please do. The last one we're going to look at is finding the domain for x squared over x squared plus 1. So I'm looking for the domain. Okay, so what do I know about square roots? I know that I can only take the square root of a non-negative number, so write that down. I always encourage you when you're finding domains to write out the restriction and then solve for x, and that's your domain. There's no guessing. So I need this to be true. That's what I need to be true. All right, so let's take a look. Okay, so we need to check out zeros, where the denominator is equal to 0. That's pretty clearly at x equals 0. Vertical asymptotes. Is this ever equal to 0? X squared plus 1 equals 0. X squared equals -1. No, not for real numbers. And another way you can look at that is you know that this is never negative, right? X squared is never negative, so never negative plus 1 more is still never negative. So, none. Okay, so that means we only have one value on our number line. -1, 1. Put in -1. Remember, this is -1 quantity squared. So 1 over 1 plus 1, all positive. Put in 1, still positive. So, is there any, so I'm looking for, what was I trying to solve? This greater than or equal to 0. Greater than 0 equals 0, greater than 0. That means for this, the domain is all reals. Or if you like to, make some script R to represent all reals, that's fine too. So that is the process for doing sign charts. We will use them right off the bat the second week of class when we do limits, and then we'll use them pretty extensively in Chapter 4 when we're looking at derivatives and what information they can give us. So this is something to really get a handle on soon, and by the end of the class, you will be able to do this in your sleep. So that's it for sign charts.